Today we are doing day 2 of section 8.3. Our objective will be to determine the type of slope and also to identify the y-intercept from graphs of lines. So we kind of did a small warm-up already with that slope worksheet where we found rise over run. On these warm-ups we're going to find slope using the 2 points. So you might remember from yesterday that we found slope, which we called the letter M, by taking y minus y over x minus x. And we talked about how it doesn't really matter which point you label as the first or second point as long as you are being consistent. So if you prefer to have your first point in the first position, that's fine. Y over x though. So we label our points. X, y, x, y, and we start plugging into our slope formula up here. So M equals, what should I plug in for y2? 1 minus y1 is 7 over x2. 4 minus x1. Alright, we also talked about yesterday how subtracting a negative is really adding, so we can change that to an addition. Alright, 1 minus 7 is negative 6, and 4 plus 3 is 7. Can that fraction be reduced? No, so we leave it alone. That is our slope. Alright, on problem 2, again, label your points if you need to. What's getting plugged into my numerator? Yes? 0 minus negative 1. I would agree with that. And what's getting plugged into my denominator, Keon? 5 minus 5. Wonderful. What is 0 minus negative 1? A positive 1. And what is 5 minus 5? 0. But we talked about this yesterday, Jamarl. What is it really? Slope is undefined if 0 is in the denominator. Slope is undefined. Yesterday, we found the slope by plotting 2 points. The sign, positive or negative, made the line look a certain way. There are 4 types of slope that we will go over in just a moment. Alright, 2 of our 4 types of slope are positive and negative. We could draw an infinite amount of examples, but I will just draw one example of each. A positive slope is going to look like it's going uphill from left to right. So it would look like it's going uphill from left to right. You don't have to place it exactly where I place mine. This is just one example. They can have a less steep slope and still be positive. Like that line is still a positive slope. They can have a really steep slope as long as it's going uphill from left to right. Or if we were to count our rise and our run, they would both have the same sign. Up and to the right, they'd both be positive, or down and to the left, a negative over a negative simplifies to be positive. So whichever example you like, draw that in your graph. A negative slope, you might guess, would look like it's going downhill from left to right. So, some example of it going downhill. It could be a smaller slope to where it's a smaller hill, or it could be a really steep slope. Some sort of downhill. Any of those work as examples. So if you want, you could even write yourself a little note that these go uphill and these are going downhill. Anybody need more time with our positive or negative slopes? Okay, the other two are 0 and undefined. We saw these a little bit yesterday when we were calculating slope. For a line to have 0 slope, or a slope of 0, it is going to be straight across horizontal. Okay, and it doesn't matter where at on the graph that it does that, but it will be a horizontal line somewhere on your graph, completely horizontal. We have seen completely horizontal lines before. We had to graph them. Does anyone remember when we graphed horizontal lines? Yeah. What did the equations look like when we graphed horizontal lines? Ellie? We could have a 0 involved. It was usually y equals a number. Do we remember doing those? When y always had to be the same thing and we got to pick what x was going to be. When we plotted these lines, when we graphed these lines, it was always y equals a number. We probably wrote it as y equals a number using the number symbol instead of writing it out. So for example, this line here would be y equals 3. This one would be y equals -4. An undefined slope, you also might be able to guess if you're good at recognizing patterns, so that instead of a horizontal line, it will be a vertical line. It's going to go straight up and down. So on this, there's not a hill at all. It's just the edge of a cliff. And again, it doesn't matter where at on the graph your vertical line is. Okay, it can still have an undefined slope there. These ones had the form x equals a number when we graphed them. X was always the same thing, and we got to change what y got to be. When we talked about these kinds of slope yesterday, just more little notes tying it all together. These ones had 0 over some other number, like 0 over 5. Undefined slopes had 0 in the denominator, like 5 over 0. Okay, so we have seen this before. We're just kind of identifying it a little differently. Let's practice identifying the slope as positive, negative, 0, or undefined. That's all we have to do on these. Any volunteers to help me out with number 1? Connie? Positive. It's going uphill from left to right. So that means it has a positive slope. What about number 2? Delaney? 0. It is a horizontal line, so it has 0 slope. And number 3, Tariana. Negative. We are going downhill on that line, so it has a negative slope. Notice that on these lines, we didn't necessarily ask for what the slope is, just if it was positive, negative, 0, or undefined. Are we ready for more examples? All right, we got a few more. Same question. Is it positive, negative, 0, or undefined? Lexi?
Negative.
Number 4, I agree, is negative. It's very steep, but it is going downhill. So it has a negative slope. What about number 5, Jaquan? That is undefined. It is a perfectly vertical line. The slope is undefined. All right, and number 6, Ryan? That is a positive slope. We are going uphill. Wonderful. Yesterday, we identified the slope of a graph. Today, we will identify the y-intercept of the graph. Does anyone remember what the y-intercept is? So, yes, so we identify the y-intercept, or we define it as the point where the line crosses the y-axis, which the y-axis is the vertical axis. So it is a point where a line crosses the y-axis. The y-axis is the axis that goes up and down. Yesterday we talked about how we use the letter M for slope. For the y-intercept, we are going to use the letter B, the variable B. How many people remember y equals mx plus b from another algebra or pre-algebra course? Okay, that's what we're working towards. We're not quite there yet, but we introduced M. Now today we're introducing B. So we're headed to y equals mx plus b soon. I know you're all very excited about that. On these examples, we are asked to find the y-intercept. So just B down here. So we are looking for the point where the line crosses the y-axis. If you need to on these, if you can't remember or always keep your axes straight, they do have them labeled with a little y and a little x, but sometimes I feel like it helps to kind of trace over it. It's not a very straight line. Trace over the axis and be able to focus on it a little bit better. So where does this graph cross my y-axis, May? At 4. If I wanted to write that as an ordered pair, what would it be, Jaquan?
0, 4.
0, 4. All right, on example 8, where does that graph cross the y-axis? Any new volunteers? Same volunteers. Jamal? -5, I would agree with that. And again, if we wanted to write it as an ordered pair, that's 0, -5. And on example 9, where does that graph cross the y-axis? Jeriel? 0, the origin. So we would call that point 0, 0. So I wrote these all both ways because usually we will just say B equals a number, but then students tend to forget that these are actually points. So I wanted to emphasize that these are ordered pairs. They are points that we are identifying. All right, a few more. We are identifying just the y-intercept. Ellie, number 10? -3. As a point, that would be 0, -3. What about number 11? Keon? So we are looking at our y-axis, the one that goes straight up and down. We are looking at where our graph crosses the y-axis. 2, +2. As a point, we would say that's 0, 2. Okay, so there's just not a y-intercept on number 12. Our y-axis is over here. Our graph is to the left of it. They are what we call parallel, which means they don't touch each other at all. So we would just say none. There is not one. We don't really use the word undefined when we talk about y-intercepts. That's really just a word we use for slope. So we would just say there is not a y-intercept, none. Now we'll combine what we did yesterday and today. We are going to find the slope and the y-intercept. We're going to find both of them. So on these examples, we are identifying the slope and the y-intercept. We're not just saying if our slope's positive or negative, we're actually finding our slope, our rise over our run like we did yesterday. And we're finding our y-intercept. Example 13, I'm hoping is pretty easy because that's a special case. Can anybody tell me what my slope is on 13? Preferably someone I haven't heard from yet today. So I've got to go pull the sticks. It's seeming that way. Okay. Kion, what do you think our slope is on number 13? Undefined. I would agree with that. Our slope is undefined. Which they didn't give me enough room to write that there. What about our y-intercept or our b? Jeriel? None. There isn't one. It does not cross the y-axis. That is always how it will happen. If your slope is undefined, there will not be a y-intercept. If there is not a y-intercept, it ought to be because your slope is undefined. Any other line should cross the y-axis at some point. Alright, moving on. Houston, do you want to tell me my slope or my y-intercept? For the slope or the y-intercept? I think you're close, but our y-intercept is going to be a little bit lower. -1 is right here. And it looks like our graph crosses it a little bit lower. So where would that be? -2. So our y-intercept is -2. But I still need my slope. Any volunteers to tell me my slope? Jamal? Okay, so if I'm using these 2 points, I kind of had to pick them out. I picked them out because they crossed nicely at the intersection of the grid, right? That's why I used those points. I would not put a point right here, right? That's not at a nice intersection of the grid. Okay, so if I'm using these points, my rise, I'm going down. Down means it would be a negative, and I'm going down how many? 2, down 2, so negative 2 over, I'm going to the right 1, so that's a positive 1. Slope's going to take a little bit more work than the y-intercept on these. Okay, so if you want, you can just knock out your y-intercepts first, and then worry about your slopes. Any volunteers to tell me my y-intercept on number 15? Yes, sir? 5, I would agree with that. Alright, and then in order to find our slope, we got to pick out a couple points. Using your y-intercept as one of the points is always a good idea if you know your y-intercept already. I think this point to the left towards the top of my graph is another nice intersection of the grid, so I'm going to use that point. If you find a different intersection of a grid that you want to use for your graph, that's fine. It should turn out the same, as long as you chose a good intersection. Okay, so I need to figure out my rise and my run to get from one point to the next. Can anyone identify my rise and or my run? Natalie. Negative 1 over 3, I agree. Okay, our line is going downhill, so we should have known that our slope was going to come out negative. We go down 1 to the right 3. That's how we got our slope of negative 1 over 3. Alright, we're almost done. 3 more. We still need a slope and a y-intercept on all of them. May, what is my y-intercept on 16? 3, I agree with that. And then we have to find our slope. So it helps to figure out what points we want to use first. Let's see. On this one, I think really our best intersection is going to be that next point right next to it. So we have to identify our rise and our run. Jamal Dixon, what's our rise and our run? 1 and 1. So our slope is a positive 1 over 1. If you just wrote it as 1, that's fine. Same thing. Alright, we are going to move on to number 17. Let me just erase that. Alright, on 17, Natalie, what is my y-intercept? My y-intercept? You were closer with 0, but that's our slope. I was asking for the y-intercept, or the b. 4. Very good. And like we just said, our slope is going to be 0. It is a horizontal line. We do not have to write it as a fraction because it's going to simplify to 0 either way. Questions on 17? That one should have been quick and easy. Alright, last one. Lots of examples today. We need to know our y-intercept. That's usually the easier thing to do first. Adrian, what is our y-intercept? 2. I would agree with that. And then we need to pick another point to help with our rise and our run. So on this one, I'm thinking this point up here would work nicely. It's not our only option, but it's a good one. So we need to count our rise and our run. Ellie, do you know what our rise and run would be?
Rise is 4 and run is 2.
Very good. Our rise is 4 and our run is 2, but we notice that that could be simplified to what? 2 over 1. So I would simplify that to be 2 over 1 or just 2 if you want to. Which is why I was saying there are other options. If we had used this point right next to it, it would have been 2 over 1. Alright, that is the end of our notes for today.